Good morning, students. Today we are going to discuss exercise 3.8. The question is factorize each of the following polynomials using synthetic division. So here we are going to do the synthetic division method, but you are going to do the factorize. In the previous exercise we have discussed using the synthetic division, we founded the quotient and the remainder. Is it clear? Now here we are going to get the factors by using the process of synthetic division. Okay, yes, so shall we discuss the first question? The question is x cube minus 3x squared minus 10x plus 24. This is the question. So as we did in the synthetic division, same process only we are going to do here also. Is it clear? Now see, it is given that we can assume the value to be p of x. P of x is equals to x cube minus 3x squared minus 10x plus 24. Now we are going to see that we are going to find the factors. So in what value if I use to get this factor to be 0? That I have to check it. So first I am substituting x is equal to 1 in this equation. So when I substitute here, I am getting the value to be 12. How? Because this is 1, this is minus 3 because x value is 1. So 1 minus 3 minus 10 plus 24. So while solving this, we are getting the value is 12, which is not equal to 0. Is it clear? So when I get it should be equal to 0, that value will be taken as a factor. For that, I am trying to substitute another value which is minus 1. When I am substituting in this equation minus 1, I am going to substitute in this equation only. When I am substituting here minus 1 the whole cube, minus 3 minus 1 the whole square, when I am substituting and solving this, again I am getting 30. So this value also could not be a factor. Then I am going to take another value which is x is equals to 2. So p of 2. While doing that time, I am getting the value to be 0. So in this process of sums, you have to wait till you get the value to be 0. Okay, if you are getting other than 0, then you should go for another numbers like 1 minus 1 2 minus 2 3 minus 3. We can go with the various values. Is it clear, ma? Till you get the value to be 0. At last you should get value to be 0. Then that value to be treated as a factor. Now this is p of 2, x equal to 2. That means when x, that value I am going to take here. Okay, so 2 you can, which value are getting to be 0, that value we have to take here, that is 2. Then write this equation now. It should be written in the standard form. Check it, the value is to be given to be in the standard form. If not, wherever you have to introduce 0, there you have to do it. Now this is 1 minus 3 minus 10 and 24. So I have taken the values like this, which is given. Okay, so normal synthetic division which we discussed in 3.7. So I'll put 0 here. You're adding 1, 2 ones are 2, and then minus 1, and again minus 1 into 2 minus 2, so minus 12. Here always the remainder should be 0 since you're going to find the factors. Okay, in factorized type of synthetic division, you should check that the remainder should come 0. If it is not coming, then your answer to be wrong. So you should get the remainder to be 0. Now what I am going to do is, again I am going to get the, because here it is x cube, so I must get 3 factors. Is it clear? Factors means you know x squared, it's a quadratic. Then we will be getting 2 factors. This is x cube. So I need 3 factors. Still now I found out only 1 factor, which is 2. Now I have to find out 2 more factors. So that what I am doing, for this value again I am trying to get another factor. So how to get another factor? You have to think and get. If I put here 3, I should check whether I am getting 0 or not here. I did, but I am not getting 0. Then I substituted minus 3. Then also I am not getting. But when I applied 4, by that time only I am getting 0. So for here, we have to do and see with various values till you get the value to be 0. At last by 4, when I do, I am getting the value to be 0. So this will be my another factor. Is it clear? So we can write x minus 2, x minus 4. Why? Because when x minus 2 equal to 0, we are getting x is equal to 2. When x minus 4 equal to 0, I am getting the value to be 4. And then this is the value, 1 and 3 it's there. So for that you have to, the expression is x plus 3. So that is the answer here. Or you have understood how we are getting the 3 factors. Since it is x cube, then we have to get 3 factors. So by this way only I got all the three factors. So I can write that these are the factors for this given expression. It's clear, ma? So half of the synthetic division which we did before the exercises, same only. Only the next part you are doing is again you are doing. Again you have what value you are getting. Again you are doing the division part. Then you are writing the factors. Is it clear? Okay. So this by this way you can complete the remaining sums. Same process only we have to follow. Okay. Then the next question is find the GCD of the following, which is in the exercise 3.9. See here it is given that to find the GCD for the following question. It is very simple. GCD is nothing but greatest common divisor. Okay, GCD is nothing but greatest common divisor. That means common. In that itself, we can understand the value. What is that? Common is nothing but we are going to write the factors and what is the common thing that we are going to take. Okay, now the first question is p power 5, p power 11 and p power 9. By seeing itself, I can tell the answer is p power 5. Why? Because p power 5 is there in other three values. Okay, but anyway we have to do and show. So for that process just I am doing and showing you here. See, p power 5, right? P 5 times. P power 11, right? 11 times p. And then p power 9, right? 9 times p, which is the common here. Just p is represented for 5 times will be the common. So I can write greatest common divisor is equals to p power 5. Is it clear? See, the same process only you should do. By seeing the question itself, we can tell if it is the question is very simple. If suppose the question is little bit tedious, this is the process. Just we should write the factors and we should write the common factor. Okay. Then the second question. See, it is given 9a squared b squared c cube 15a cube b squared c4. This is the question. So I have written the factors for this. 9 means what I will write? 3 into 3. And then a squared, a into a, b squared, b into b, c cube, c, c, c. Again the same like that. Then what are the common things in this? 3 is common. So take 1 3. And a is common for 3 a's are there. Here also I have 3 a's. So you can take, okay, 2 a's here. 2 a's here and we have 2 a's. So you can take 2 a's. And b, 2 b's are there. So you can take 2b. And c, 3 times were there. So that you can take. So but after writing all these common factors, then you can write like this: 3 into a squared into b squared into c cube. This completes the process of this sum. Is it clear, ma? Then in the second Roman letter, we have another question that is also find the greatest common divisor of the following. See, in the second Roman letter, find the greatest common divisor of the following. In that first question, it is given that 2x plus 5 into 5x plus 2. Is there any common factor? Is there? We don't have any common factor here. Yes. So because we could not get any common factor here, so you can write that there is no common factor, but the greatest common divisor is 1. Because 1 is a factor for all the values. So even though you don't have any common factors, you can write the greatest common divisor is equal to 1. Okay. Then the next question is a power m plus 1, a power m plus 2 and a power m plus 3. It is nothing but a power m plus 1 can be written as a power m into a. We know the formula a power m into a power n is equal to a power m plus n. Is it clear? By using that formula only we are writing this. If you want, I will write and show you the formula. A power m into a power n. See here it is given that a power m plus 1. Okay. So a power m into a can be written as a power m plus 1 like that. A power m into a power n. It can be written as a power m plus n. That is the format which we used here. So when the power are different, okay, but here the values will be the same. So what we can do, we can just add it. When it is in into, it is in the form of into. A power m into a power n is equal to a power m plus 1. A power m by a power n, which is equal to a power m minus n. Is it clear? This is also known one only, but we are using only this formula only here. So by using that, I am getting value a power m into a and a power m into a squared. So a into a cube. So a into a. Then what you can do here is common you can take. So a power m and then only one a is common. So right. So a power m plus 1. This will be the answer for this question. It's clear, ma? Thank you.